So there are some theorems that can shorten up the amount of information that you need to prove triangles are congruent. First one we're going to look at is the ASA, which stands for angle, side, angle. And it states that if two angles and the included side of one triangle are congruent to two angles and the included side of the other triangle, then the triangles are congruent. So we don't need all three sides and all three angles. We just need two angles and the side in between. Now, the two angles and the side in between, that's very important that you identify that it is two angles and the side that is in between, and that's the reason it's written this way with two angles and the side is in between them. The S is between the two A's in the way that we write it, because it's two angles and the side is in between. So here's some examples where we can start looking at this. We do have two angles, 45 and 61. And then the side in between has the length of 2.3 centimeters. So we can see that the 61-degree angle matches with the 61-degree angle. The only problem here is we have 74 degrees up top, which means we don't know what angle D is. That's the first thing we're going to do. So 61 plus 74 is 135. To figure out the measure of angle D, we're going to subtract that from 180, and we get 45 degrees. So now our 45-degree angles match up, the 61-degree angles match up, and then we have the side in between with 2.3. So yes, the triangles are congruent because we have two angles that are congruent and the side in between. We could say angle A is congruent to angle D. We could say angle C is congruent to angle F, and then the side in between is AC is congruent to DF. So we have two angles and the side in between. So for our next example, we've got a 31-degree angle and a 110-degree angle with 62 inches between. So here's our 31-degree angle. There's 62 inches. This angle up here would need to be 110, so that we have 110, 31, and the side in between. So figure out what that side is. 31 plus 38 is 69. 180 minus 69 is 111. So the angles are not congruent, so therefore the triangles are not congruent. It's off by 1 degree. On our next example, we've got angle B and angle C are congruent. We can see the tick marks. We have a 90-degree angle here, which means we also have a 90-degree angle on the other side. So we have two angles that are the same. Also, we have the side in between. So yes, they are congruent because of angle, side, angle. We have two angles and the side in between. You could list out all the angles and sides again. Angle B is congruent to angle C. BD is congruent to CD. And then angle ADB is congruent to angle ADC. We have the two angles, the side is in between them. And for this next example, we have 72 degrees, 38 degrees. That means that this third angle That has to be 110. So 180 minus 110. The third angle is 70 degrees, which does not match with the 67, so those are not congruent. Now we're going to start writing some proofs. We just start with the given information. Now, as you're doing these proofs, I suggest that you mark them, whatever it is that we're going to write, we're going to mark it in the triangle also. So the first statement we are going to write is the first given. Angle MQP is congruent to angle NPQ, and that was given. And then we mark it in the triangle. So you're going to find angle MQP, MQP, so that's that angle right there that we just traced out, and NPQ, NPQ, that's this angle over there. Then we have another given statement, angle MPQ is congruent to angle NQP. That was also given. Since those are different angles, we have to mark them different, so we're going to use two arcs when we mark it this time. MPQ, two arcs. NQP, two arcs, just so we can tell them apart. I also color-coded it for you. So that was given. And now here's a property that we haven't really dealt with yet. It's called the reflexive property. And it's saying QP is congruent to QP. It's congruent to itself because it is itself. Whenever two triangles share a side, if they overlap like that, and they share the same side, then it's got to be congruent to itself so you can use that side. And that's called the reflexive property. So now looking at these two triangles, we have two angles marked with the side in between, congruent to two angles in the other triangle with the side in between. So that means the triangles are congruent, which is going to be our proof statement. It's always going to be our last thing we write, is always the thing we're trying to prove. And the reason those are congruent is the thing we've been talking about this whole lesson, angle side angle. You can abbreviate it ASA. So for our next proof, we're given angle A is congruent to angle C. So we're going to write it. And we wrote that because it was given. We're also going to mark it in the figure. Angle A is congruent to angle C. Next, we're told that E is the midpoint of AC. So we'll write it down. Because it was given. So that doesn't tell us anything's congruent, so we don't have anything to mark. You only mark the diagram when you say something is congruent. But this is important. E is the midpoint. Since it is the midpoint, that means it's the two halves, the two sides are equal. So the two sides of AC, this side and this side. AE is congruent to CE, which is exactly what is written next for you. AE is congruent to CE because that's what midpoint means. That's the definition of midpoint. Midpoint means it is two equal pieces on each side. So now we wrote something with congruent, so we marked it. Next, step 4 says angle AEB is congruent to angle CED. AEB, this angle, is congruent to angle CED, which is right there. Now that was not given to us, but it is in the picture. We can see that those are angles that are across from each other. So that's called vertical angles. And we know that vertical angles are always congruent. So if you see vertical angles in the diagram, you can always write it down in your proof. Just like if you ever see reflexive, a side that's shared, you can write that down in your proofs also. Doesn't need to be given because you can see it in the picture. So now we have two angles, the side in between, two angles and the side in between. So that's enough now to say that triangle AEB is congruent to triangle CED, the thing we are trying to prove. And we said that that is enough now because we have two angles, the side in between, which is better known as ASA, angle, side, angle. So we always start with the given. We're going to write down angle JLM is congruent to angle KML. JLM, that's this big angle. KML, that's that big angle over there. It was given. Also, angle JML is congruent to angle KLM. That was also given, so we'll mark it in the figure. It's that small piece right there. KLM, that's that smaller piece. And it's not given in the words, but it is given in the picture that they do share a side. There's a side that they both have here. They both have this bottom piece, LM. So you can write it. It will always be congruent to itself. That's called the reflexive property. A little difficult to see because of the overlap going on here, but we do have two triangles. They have the green and the red angle with the side in between. So that is enough for angle JML to be congruent to triangle KLM. And again, that was angle, side, angle. Two angles and the side in between. Start by writing the given. Angle S and angle U are right angles. S and U are right angles, and then you can mark it. Now, since they are right angles, they are congruent. You always have to write the congruent statement. Angle S is congruent to angle U because all right angles are congruent. RV as our next given statement. Bisects SU. That was given. RV cuts SU in half, which means that this side, ST, will be equal to TU because it was cut into two equal pieces. That's what it means to bisect. So the definition of bisect. Then the only thing missing is visible in the diagram. We've got vertical angles right there. Angle RTS is congruent to angle VTU. Those are vertical. So the triangles are congruent. because of angle, side, angle.